Yeah, thank you, Marco, and thank you all for joining today. You already learned now how multi-criteria optimization works from a technical point of view. And what I want to show you is how we at BASF try to leverage this. So we have a collaboration ongoing with the Fraunhofer Institute for a couple of years. And one of the results that is coming out of this is Qritos. Qritos is our tool for multi-criteria optimization that we, together with the group of data science for material, built up, and that builds up on this technology co-developed with the Fraunhofer Institute. And we were thinking, okay, how can we leverage this best in the world of R&D that we have here at BASF? So we thought about which challenges are there in the research and development that will come up or keep us busy in the next 10 years. And I think all of you know that innovation cycles are very fast already. We assume that they will be even more fast and that we have to come up with a way to keep innovating and to keep up with the pace here. We think that it is important to have some tools in order to cope with the lack of skilled workers that we will have in future. So the workers that we have here may go to retirement, then the new workers will switch position much more often, and then what you lack is the expert knowledge that people gathered over decades, and you have to find a way to cope with this. Another important pillar will be data. So we already see that there is an increase of data, and we see that this will be rapidly increasing over the next few years, and you have to find a way to use all those data that you are generating. Data transparency is another topic to this. We have more data, and it will be possible for a lot of people to have a look into this data. Transparency will grow massively, and it will be very easy to compare products from one and another. So you need to be informed, and you need to think of, okay, what happens if my customer is informed about everything that's going on in the industry? And also we, of course, see a lot of automation coming into the lab as well, being it high throughput screening or other technologies. We don't expect that to slow down at all. And all of those things give reason that AI and machine learning services will also be of growing importance for the product development or for formulating industries, because we believe they will leverage this knowledge and will give solutions to the R&D people that will be really helpful in their day-to-day business. And we didn't want to just have a look at it. We wanted to be part of it, and we wanted to develop it for us as well. So let's take a step back. Let's think about a normal problem, a normal challenge in a formulation business. You probably have, like Michael already said, sometimes formulations that need to fulfill several characteristics at the same time, and those are conflicting. Michael told you about the cost and the deviation from spec, but it could also be the yield and the quality, or it could be some technical parameters like, I don't know, the gloss, the stiffness, the viscosity, whatever you have in your day-to-day business, that are challenging because they are conflicting, and you have to kind of find a trade-off. And we leverage now those algorithms to create the Pareto optimal set of formulations and to show you the Pareto frontier and make you able to navigate on that. So what we see is by using this, we will be able to reduce our time to market because we save some iterations, right? When we know already what the implications of several changes in the performance are, then we can reduce time to market for further development significantly, which also, of course, then will lead to a higher development efficiency. And a nice side effect on that is that you have this kind of knowledge democratization. You have standardization here. You need standardized data, and having those standardized data will help you with several other applications in the future as well. So let's have a very simple example. Let's say you have an exemplary project. Maybe in one of our BASF labs, there is someone having a product that only consists of one reactant and one additive, and he wants to have a look at it. Those two components will then be at a certain temperature steered together, and the only thing that we're interested in is the yield and the quality in this case. So the first step to do is always come up with an experiment plan. You need to conduct some experiments in the lab, and you need to come up with those. there are several options for those. Sometimes people say, I have so much experience, I come up with this experiment plan by myself and measure the results. This would be kind of a trial and error. And we oftentimes say, please do it with a design of experiment, with DOE, so with statistical trial planning. This helps when you do the experiments to broaden the solution space, and therefore you get the most out of the experiments that you have made. Nevertheless, this is kind of a prerequisite to using Qritos. So whatever a lab researcher has done, in the end, we need this data set in order to use Qritos. And what we then do is we find predictive models and we optimize them. So at first, we will look at the responses and we will try to find a very good model here. In this case, the values of 0.99 are close to perfect. Perfect would be 1. Not always they are that good, but we try to find models that are able to predict the values that not have been measured in the lab. And if we found those models on the different responses, then we will create the Pareto front. Now, in Michael's example, the optimum was in the bottom left. In our example, it's in the top right, but I guess you get the point. So we have the feasible region with the not performing formulations. We have the region where we would like to be, but we can't be here due to physical limitations. And we have the Pareto front, which we have calculated by then separating both from each other. And now I want to switch to our Qritos environment. So I switch to my web browser. Qritos is available in the web browser for all BASF employees. And we also have possibilities in certain cases to give access to external people when the collaboration makes that necessary. So what I want to start with is an example where we bake a cake. Let's say you have baked 40 cakes in the past. You have 6 different ingredients that are shown down here. You have the temperature or the time you measured it, and you put this all in an Excel file. And now you want to optimize the next cake that you are baking. And optimal for you means that the cake has a minimum of calories, a maximum of taste, that it has a certain degree of browning, and is at a very low price. So those are 4 different objectives. And you have 7 input factors here. And the beauty of Qritos and the heart of Qritos is now that I can use those sliders and in real time see which implications has a change in one objective to all the other objectives. I can do that with all the objectives, of course. And I also see, okay, what formulation is needed in order to achieve exactly this performance. So I can do the multi-criteria optimization in a very easy way without knowing much about Pareto fronts or about data science or about statistical methods. I can really just drag those sliders and find the best compromises. And I can do that also the other way around. So maybe I want to have a formulation that consists not of nuts, but only of the other 5 components. I can do that, and I can instantly see which is the optimal solution here. What I'm also able to do is I can use those red triangles here, introducing constraints. So I could say calories, yeah, I just want to have a look at the bottom 20%, for example. And then you will instantly see that there are some red lines appearing. And those red lines indicate areas where you can't be with your formulations anymore. So if I try to go here, I will be drawn back. This is not a bug, this is a feature. And I will not be able to exceed this point. And therefore I can see, okay, what is the maximum taste that I can reach given this limitation in calories? And I also can see that I will be restricted in some of the other parameters. For example, in chocolate, this red bar here appeared, so I will not be able to use the 35% anymore. I can only go up to, I don't know, 7.6%. And I can play with this. I can also limit the space here that I have in terms of my factors and see which is the optimal formulation. And when a scientist then found a formulation, he can mark it. Maybe he has another formulation that he's interested in, then he would mark it as well. And they will be appearing in the bottom half of the tool. can be exported as Excel, because although we are quite happy with our predictions, we still would tell you to do one verification trial before you go into scale up. This was one example. I want to show you a real example from the BASF portfolio as well. So this is from the Laromer portfolio, which is in the furniture and flooring area. We have a colleague here who is a technical colleague and who already had a data set. He had very, very good data. And so it didn't take us very long to find the models and didn't take us very long to do the optimization. And what he now uses with his customers is this view. So he was interested in 4 technical parameters, basically. And on the bottom half, you have the Laromer portfolio, which BASF sells. And now he can go to the customer and can say, okay, you want to have a very high hardness, you want to have a very high creep. Let's just see which formulations are possible here. And you instantly see there are some Laromers that don't qualify for this use case. And there are others in the formulation that qualify for it very, very well, and that will be needed for that. Now, if I say I'm not interested in this Laromer, for which example whatsoever, I can just use the red triangle again, limit it to 0, and then of course I will see a lot of changes. But I will see another configuration in the same area of performance with the same factors, of course, as well, or with the subset of the factors as well. So he's able to do consulting with his customers on a whole new level, on a whole other level of detail, because he instantly can show what it means. And of course, if we wanted, we could also include cost here as well. So we could also show you which performance would be available for which price. Now, those were 2 examples. This is the example in the written form, but I already showed you what we did there. So let me stick to another example, which we did. We had a moisturizing cream that we needed to optimize. And optimizing meant, okay, we have a pH value here, we have a certain target for that, we have a viscosity here, we have a certain target for that, and we want to reach that at the minimum cost possible. And we did the whole experiment here. We gave consulting on how to create the design of experiment. We were there when the experiments were done, did the modeling, did the optimization. And in the end, we gave those slider views to our lab scientists, to our customers. And what they found were 2 very interesting formulations. One that was 15% cheaper than their current formulations, with better performance in one technical parameter, and one same performance in the other technical parameter. And the other formulation was a cost decrease of 8%, while being very close to the targets in both of the technical parameters. And in the end, it's now their decision to talk to the product management, talk to the marketing for which option they want to go. But I would say in both cases, they have quite good results to report. And they were quite happy with this. A third example, and this is the last example that I want to show you, is maybe even more technical. We were able to predict friction coefficients for screws. So we had an application with a top coat for a screw, and it was necessary to measure how the friction coefficient is affected by a couple of inputs that you see here. And then we measured the results for 8 different parameters, basically. So we had 4 materials, 1 head value of the screw, 1 treat value of the screw for each material. So we had output parameters. And now, by using all those data points that were already created, we were able to give a prediction how those input parameters interfere with those output parameters. And now, when talking to the customer, it is possible to save machine downtime, because you can save iterations on the development of a new top coat, or in the introduction of a new top coat to a new production line. And also, you're, of course, very, very much faster than the competition in replying to customer requests, because you don't have to go to the lab and measure the results first. You can give a first indication based on Qritos, just like this. So You see that Qritos can be used for a variety of applications. One is to speed up the decision making. Once you have your portfolio analyzed and you have it modeled and optimized here, it's very easy to sit together and make a discussion and then find a solution that is appropriate for the use case you're talking about. And also you could do that with your customer. So it doesn't have to be an internal project. It can also be showing either your customer what you were doing or just showing him the results that you were able to come up with in a faster manner than before. And the third point again is you make everyone an expert in your lab. So if you have a new lab technician and he has to go through 20 different Excel files from the past, then it will be very difficult for him to understand what are the interactions, what are the influences that are shown here. How can I use the data? With a tool like Qritos, it's a lot easier, I would say, to get up to speed. So we have a very clear picture in mind how the future could look like. Normally, when we talk to our departments, we aim for a quick pilot project because we have to prove that we generate business value for them. Then we find the not most complex, but also a not very easy pilot project that we are doing. And then once we finish this, or once we found out that this area of the industry maybe applies to Qritos, then we enable key users to use Qritos independently so they can make use of data science without being data scientists themselves. And this is also where we want to be in future, that we can make data science-based formulation optimization and data-driven decisions by using tools like Qritos and helping our scientists to get the most out of their R&D. And this is what I wanted to show. If you have questions or remarks afterwards, you can, of course, reach out to us later. But also, I think we have some time for a Q&A now.